This is 4-3, modeling with quadratic functions. What we're going to do today is take 3 points and figure out the equation of the quadratic in standard form. So you're actually going to have to solve a system of 3 equations with 3 variables. So we know standard form, y equals ax squared plus bx plus c. We're going to plug our 3 points into that, right? So y equals ax squared plus bx plus c. That is the standard form of a quadratic. Starting out with an easier one here that starts out with a 0, 0. So we know every point is x, y. So we're going to substitute 0 in for x, 0 in for y into standard form. So y is 0 equals a times x is 0 squared plus b times x is 0 plus c. So that would just simplify to 0 equals c. So that's our first equation. That's what's going to make this one a little prettier than the other ones. Second one, we have negative 1, negative 2. So this is our xy. So y is negative 2 equals a times x is negative 1 squared plus b times x is negative 1 plus c. So we have negative 2 equals negative 1 squared is 1. We've got 1a because we wouldn't write a1. B times negative 1 would be negative 1b plus c. So there's our second equation. And then we would do the same thing for the third equation. So 1, 6, we have xy. So y is 6 equals a times x is 1 squared plus b times x is 1 plus c. So 6 equals 1 squared would be 1a plus 1b plus c. So those are our 3 equations to make our system. I'm going to rotate them and put the number on the right like we're used to seeing them. So we have, let's see, orange, a plus b plus c equals 6. Green, a minus b plus c equals negative 2. And then red, c equals 0. So there's our system of 3 equations with 3 variables. You can use any method that you want to solve. Since we've got that c equals 0, I'm going to use substitution on this one. I'm going to substitute this into the first and into the second. So those are just going to go away, right? The c's are going to be 0. So I'm going to have a plus b equals 6. I'm going to have a minus b equals negative 2. Pretty. This is my system of 2 equations with 2 variables. I'm going elimination because the b's are opposite. So I'm at 2a equals 4, which makes a equal to 2. And then to find b, I can just substitute the 2 back in. So I have 2 plus b equals 6 to find out that b is 4. And I already know that c is 0. So now I would just substitute a, b, and c into standard form. I'm going to replace a, b, and c. So our quadratic equation would be y equals a is 2x squared plus b is 4x plus c is 0. That would be acceptable, or we don't usually write a plus 0, so you can just go y equals 2x squared plus 4x. So that's how you take 3 points that are on a quadratic equation and figure out the quadratic equation. All right, so same game here. We've got 1, negative 2. So y is negative 2, x is 1. So negative 2 equals a times 1 squared plus b times x is 1 plus c. So that'd be negative 2 equals 1a plus 1b plus c, first equation. Then I would do that for the next point, xy. So y is negative 2 equals a times x is 2 squared plus b times x is 2 plus c. So that's negative 2 equals 2 squared would be 4a plus 2b plus c, second equation. And then to get our third equation, we'll plug in 3, negative 4. So negative 4 equals a times 3 squared plus b times 3 plus c. that would be negative 4 equals 3 squared is 9a plus 3b plus c. So there's our system. I'll rewrite it to make it pretty. So we've got a plus b plus c equals negative 2, the green one. 4a plus 2b plus c equals negative 2, the red one. And 9a plus 3b plus c equals negative 4, the orange one. So now it's totally up to you what method you want to use. I'm going to go elimination on this one. I like those c's. So I'm going to multiply the first equation by negative 1. And then I'm going to add that to the second equation. And then I'm going to add it to the third equation. So second equation, I've got 4a plus 2b plus c equals negative 2. Multiplying the first one by negative 1 is negative a minus b minus c equals positive 2. When I add those up, the c's are gone, and I have 3a plus b equals 0. So now third equation, 9a plus 3b plus c equals negative 4. And again, this is just one way to do this. There are many ways. You can solve that system however you want. Multiplying the first one again by negative 1 is still negative a minus b minus c equals 2. So c's are gone again, and I have 8a plus 2b equals negative 2. So now I can create my system of two equations with two variables here. So I have 3a plus b equals 0 and 8a plus 2b equals negative 2. So I'm going to go elimination, multiply the top equation by negative 2. I'll just move it down here. That gives me negative 6a minus 2b equals 0. So then when I add those up, b's are gone. I've got 2a equals negative 2. So I find out that a is negative 1. Now that I know that a is negative 1, I can substitute it back in. So I have 3 times a is negative 1 plus b equals 0. So negative 3 plus b equals 0. So b is 3. Now that I know a and b, I can plug those in to find c. So I'm going to go with this pretty top one. So a is negative 1 plus b is 3 plus c equals negative 2. So combine like terms, 2 plus c equals negative 2. Subtract 2, we get negative 4. So I know my a, my b, and my c. I'm going to need some space here for the answer. So now I just substitute those back into standard form. So I would have y equals a is negative 1 x squared plus b is 3x plus c is negative 4. So I'd write minus 4. So the equation of the quadratic that goes through those 3 points on the parabola is y equals negative x squared plus 3x minus 4.